All right. So tonight's lesson is actually really going to be 8-4 and quickly 8-5, and I'm actually going to do a few problems from 8-6, even though you don't need to do that, just because they're all basically the same type of problems. But I know there's some concern with some of the stuff from 8-3, and it really leads into 8-4 anyway. So we'll do a few of the problems from 8-3 first. So there were really two types of problems in 8-3 that we talked about. One, you were trying to figure out the probability given the z-scores. And one, you were given the probability and you were asked to find the z-scores. So both directions. So the first set of problems that we looked at were really, you were given the z-scores and we're looking for the probability. So with these, the key really is to figure out where you're looking to then look at that chart to find the answer. So for example, if we look at the first one, it was from 0 to 0.79. So we know 0 is right in the middle. So that's 0. And then 0.79 somewhere over here. It doesn't necessarily have to be exactly. So we're looking for this space right in through here, that probability. So we find, remember on that chart, the probability is always from the left over. So we're going to go this direction. So we need to find that one and then that one. So we need to find those 2%. And then what do we do to those 2% to find the answer? We subtract. So actually, pull one of those charts out so I have one. So what's the probability, or what's the percent for a z-score of 0? The red or black line. Sorry. So a standard of 0. Everybody have their z-table? Anybody not get one last class? Okay. If you, yeah. You're welcome. I have a few left. Oh. And save one just for him. No. So 0, if you look at the table, is actually point. That's okay. It's 50. And if you think about it, it should be 50, right? Because half, that 0 is right in the middle. So the first half is 50 and the second half is 50. So that's 0.500. Now look for 0.79. So 0.7 is 0.78524. Everybody able to find that one? And now we're looking between those two, right? So we subtract. So my A is 0.28524. That would be the probability between 0 and 0.79. Okay. This side. All right. Does that make sense? Okay, find me B. All right. So what did we get?
0.408.
I think you missed a 0.
Oh, okay.
It's 0.05821.
Oh, yeah, that's what I did.
The only reason I know that is when I typed it in my calculator, I forgot to type the 0, and that's the number I got. So you should have gotten 0.93189. Again, same concept. Find the 2. You're looking between them. Subtract. Okay. All right. Yeah, don't miss the 0. It's 0.0, not 0 point. That could make a big difference in your answer. All right. The other type of problem is the other direction. So for this one, it says find the value of z such that 0.7458 of the area lies under the curve between negative z and z.
This is the same as C for the other problem.
No. You want me to do C?
Well, it just had a second value, so I would.
So you just do the 1. But I can do C. I can do C first.
Yeah.
Okay, no problem. I can do C.
Sorry.
You're fine. I don't mind. All right, so let's do C. So 1.89. And they want greater than that, right? So that means they're looking for this spot over here. Yes.
Are you putting it on the right side because it's over like 0.5?
I'm putting it on the right side because it's positive. 0's in the middle. So this way is positive. That way is negative.
So you just want to put it in that area exactly?
No, I just picked a spot. I knew it was over on that side somewhere. All right, so I'm looking for this spot right down there. Okay, so on your table, find. So in this case, we're going to look for the 1.89, which is,
Or one minus.
yes, 0.97062. Now, I want just the little spot on the other side of that, right? So what's the whole probability?
That-
Everything is what? Nope. What's the, it's
Oh.
between 0 and 1. What's the entire graph going to give you if you're at 1, right? So I want everything except for that. So I'm going to do 1 minus that. And that's going to give me that little space over there. So 1 minus 0.97062. So 0.02938. So that's the probability on that side. So if they're only giving you 1, and it's on the right side is what you want, that little side there, it's going to be 1 minus it. If it's on the left side, whatever number you got is the number you're, because that's what you're looking at. The chart's giving you from the left side. So I might as well do D since I did the other 3. So if we're looking at D, so that's over, it's negative. So that's on this side over here is what I'm looking for. So again, we're going to there. So look at our chart and find negative 2.77. So 0.00280. And that's my answer. We don't have to do any subtraction for it because it's from the left.
So if it's a negative, you don't have to do any kind of subtraction from 1. That's just
Well, no, it just depends. If I was looking for this side, I'd have had to subtract from 1. So it's a matter of which side they're looking for. This chart's always going to give you from the left. So if they're looking at the right side, you're going to have to subtract from something. Or if they're looking at in the middle of two things, you're going to have to subtract from something.
Do you add one?
No, in this case, that's the answer. I'm done.
Oh, it's fine, negative.
Yeah, because we're always looking from the left. And that's the piece I wanted. That's why I like the little the picture, because you draw where you're looking, and then you can figure out, okay, that's what I want. Okay. All right. All right, let's look at this one. So there's a couple pieces of information in this one that's supposed to help you out. The biggest one is it's negative z and z. That means z is going to be the same value. That's actually extremely important in this case, because if that wasn't the case, you couldn't do this problem. Okay, that means you're looking from the center out. Okay, so I'm going to I pick a line over here and a line over here. That's negative z, and that's z. And in here is 0.7458. Okay. So your goal is to figure out, like, okay, what piece do I need to find so I can look at my table and find the answer? Well, if I'm splitting this in half, so let's just look at the middle here. If I split this down the middle, how much is going to be on this side of that 0.7458? It's going to be exactly half of it. What's half of 0.7458?
It was sugar.
0.3729.
So in this side is 0.03729.
Oh, so did you take that from top 5?
Yes, exactly. That is actually the exact thing. So I'm going to take that number. Okay. Remember my chart, right? The chart's telling me what? From the left, correct?
Yeah.
Okay. So I need to find something from the left. So if I can find this piece here, that's going to give me that z. Okay? So I know the piece in the middle. If I subtract that from 50, which is that half, I will get the piece that's on this side over here. And I'm sorry, I'm doing in yellow, which most people probably can't see. So I'm looking for that piece right there. So if I do minus 0.5, I get 0.1271.
From 7.74.
That was this minus 0.5. Not the 0.7458. Okay. This is split, right? It's in the middle. The 0.7458 is this whole section right here.
Oh, hold up.
Okay.
I mathed wrong. Wait a minute.
So you could, I don't know how Hawk's does this. You could do this one of two ways. You could have taken this away from 1 and then divided that number in half.
I still don't understand. I'm doing it on the calculator and I'm not getting that.
What?
I'm doing,
That?
yeah, I'm not getting that.
What did you get?
So you take 0.5.
Minus 0.03729.
I don't.
Oh, wait, it's not. No, sorry, I messed it up. It's not the zeros before it. It's
It's
0.3729.
okay, that's why I was like, wait a
Yeah,
minute.
the zeros in the wrong spot.
Okay.
You're not wrong. I just put the dot in the wrong spot. Dot's there. Okay, now we should get the right answer. All right. Look in your table for 0.1271. 0.1271. It's going to obviously be on the negative side.
-1.14.
Yep. And the other side is also going to be the 1.14. Just the positive version of it. Mhm. That's how you do that.
How do you decide whether it's positive or negative?
You're in this question, the way it's worded, you're always going to both.
Because on Hawks, sometimes it wants positive and sometimes it wants negative.
Okay, so depending on depending on what the question asks, this question you actually would want both.
But that is the answer after you subtract that.
Is a 0.1 or 1.14 and 1.14. So negative 1.14 and positive 1.414. So there's two different types of questions on Hawks. This is the one where they're giving you the value in the middle and you have to figure out both things. And they're going to want both, the negative and the positive version. If it's just looking for a single value, then it depends on where the percent shows up. Okay, which I'll do one of those in a second. I want you to try number 19 first, though. So do one very similar to this one, and then I will do one that's just a single number one. And then we're going to go on to the new stuff, which is literally a continuation of this stuff anyway. So not the end of the world. You'll still get more practice with this.
Does it have to be that exact number or just something close?
You're not going to get it exact. You probably won't get it exact. You want to get the closest one to it. Point 0, 2. All right. Oh, I'm on the wrong screen. Wait, what?
Wait, what?
I knew it.
Okay, good.
Oh, wait, no.
You're
Why
right.
is it 0.65?
Because it's basically between the two.
That's what I
1.96 would have been fine. 1.97 would have been fine. And then the positive version of that as well. Notice I did this one slightly different than I did the last one. This one, I subtracted it from 1, and then I just divided that by 2. Because I'm looking for what's in the outside edges. So if I take away what I want, that's going to give me the outside edges just divided by 2 because I have an equal amount on either side. So that's why I did it that way this time. It doesn't make a difference if you divide by 2 and subtract by 0.5 or do 1. It's going to give you the same answer at the end.
The way Hawks literally did not exist.
Yeah.
tutor. That's why I texted you the other night why Hawks didn't explain their answers because the tutor didn't. It gives you
Yeah,
the
the
picture.
tutor-
Basically gives you the
tutor
answer.
only gave the picture.
All right. So here is this one. Now, when you're doing this problem, So the key with this problem is putting your line where they're asking. So in this case, it's asking for 0.05 to the left of Z. Okay, so that means I want 0.05 left of whatever the line is going to be. So I'm going to put my line somewhere over here because all I want is that to be 0.05. Okay, that's all I want over there. If it said 0.05 to the right, I had to put my line over here because I want the little spot over here. So you kind of have to look at the wording and figure out where your line's going to be because that's going to tell you if it's a positive Z or a negative Z. Okay, if the line is to the left of the center, it's negative. If the line's to the right of the center, it's positive. So in this one, I'm looking up 0.05 and 1.6 something. 1.645. So it's negative 1.645 or negative 1.64 or 1.65, depending on which direction you want to go.
Can you repeat the whole?
So it says, I want this to the left of Z. Okay, this is my Z. I want this to the left of it. What I'm looking for is to the left of whatever line I'm looking at. I don't care. Believe it or not, it doesn't make any difference where you draw this line. So I could draw my line here. I could draw my line over here. It's not really going to help you if you draw it over there. Because if this is to the left, it's got to be less than 50%, right? Oh, that's looking at the chart. So I'm looking at this. That's 0.05. So look at your chart and find 0.05. And you should get negative 1.645 or negative 1.65 or 1.64. It's one right in the middle of it. Yeah.
Am I looking at the chart wrong? Because
Yeah, I'm like, am I looking at the chart?
yeah, I went to 0.
No. You're not looking. That's not a Z. That's a percent. You're looking for Z. So you're looking in the box here. Right. You're looking inside here.
You're not looking on the side. Like you're not looking at this. You're looking.
Yeah.
I just got it.
So you want to. So they're either going to. So in these problems, they gave you the Z. So you're looking on the side to find the percent. On these problems, they're giving you the percent. You need to find the Z. So you're going backwards. So you need to look in the middle of the chart to find 0.05. And that's where I got the 1.64 or 1.65. And it's literally right in the middle of it.
Okay, so if you're trying to find it, right?
Mhm.
I'm not trying to.
Okay.
But
No, go ahead.
anyways, why is it 0.050, not the next one, which is 0.051 or 0.6? You know what I mean? Like they're all a version of 0.05.
You want to get it as exact as possible.
Okay.
So you're really looking for 0.0500. I think it goes to 5 places.
Okay.
Yeah, you're that. You're looking for that.
So the closest thing to that.
Right.
Oh, got
And
it.
at 1.64 is 0.05050, and the other one is 0.04947. So somewhere in the middle of that is the right answer.
I was like, the next one's 0.05.
Yeah. So you got negative 1.64.
Does it matter?
I don't know on Hawks which one they want. Believe it or not, the exact answer is what I just gave you there. Because this number that this one's looking for is going to come up a lot in the future classes. And that's the number you're going to use for Z for that one. Oh, yeah. I would take 1.64, 1.65, that one. Yeah. Because if you're going to get it wrong, you're going to be way off. You're going to be way off if you get it wrong. If you're like within that, you're fine. I know you looked right. All right. Now, the only thing different we're doing tonight, the only thing is we're going to look at realistic type situations, which means my mean is not going to be 0 and my standard deviation is not going to be 1. So I need to be able to convert this back to something that I can use to chart and everything else on. Okay. That's where that Z equation at the very beginning comes up to play. So your Z score is your value minus the mean divided by the standard deviation. Always. So that formula is going to be able to get you to go back to do exactly what we were just doing before. Okay? So if I want to find the probability of a normal random variable with a mean of 10 and a standard deviation of 20, that lies between 10 and 40. So let's look at 10. Let's find the Z-score for 10. So I have my X is 10, my mean is 10, and my standard deviation is what? 20. So 10 minus 10 is 0 divided by 20 is 0. So the Z-score for this one is 0. Now let's find the one for 40. Same concept. 40 minus 10 divided by 20. And that one equals 1.5. So this Z is 1.5. Now we're going to go back and do exactly what I just did in the first 30 minutes of class. What's the Z of 0? And what's the Z of 1.5?
Oh, you did the biggest and the smallest.
Yeah.
20.
Did I screw that one up? No, 1.50. 0.933. Go down to the fourth. So you're looking at 1.5 for Z. And then 0. To give you 0.93319.
Oh.
Got it. Okay. No problem. And we're going to subtract those, just like we just did in the first class. This is like almost exactly the same as the very first question we did tonight. And we subtract them. So 0.43319. That's the probability. So the only step that's added to make these realistic type problems is find the Z. And it's always going to be that formula. That's never going to change. Okay? Yeah? No problem. I have 2 pages. I can flip to the next one on the next screen and you won't even know it. You're welcome. All right, let's look at this one. You can get. They have the little stickers with the actual like graphs on them. They have like little post-it notes with graphs. You can get post-it notes with the bell curve if you want. Or you can literally just print off a sheet of bell curves. Makes it easier than trying to draw them every time. It definitely will help you understand where you're looking. To physically have the bell curve and just draw out lines and stuff on it. It definitely does help. All right, so this one. What's my mean? 400. Oh, right, there we go, 400. And my standard deviation is 100. So my mean and my standard deviation is 100. My score is 644. So that's going to be somewhere over here. I don't know exactly where. Somewhere over there. Okay. And they want to know what fraction of students taking the test exceeds your score. So do they want this side, A or B side? They want B, exceeds. So they want that. Okay. Now we're back to what we were doing before. So take the word problem, translate it to a picture. And now we can do the other stuff.
So are you still doing x minus mean?
Yep. So it's 644 minus 400 divided by 100. So 244 divided by 100 is 2.44. So that's my Z. Yeah, 2.44.
And put on the chart. It's,
Now we're looking at the chart. So that side right there is 0.99266. Is that what I wanted? Right, because I wanted the B side. So we're going to do 1 minus that. So 0.00734.
I always think it's way more complicated than that.
It's not. That's literally why. Like, this looks complicated. It looks like the way the word problem is. It looks like it's really complicated. The hardest part is getting the words and making the picture. Because once you get the picture, you know all the other steps. It's like all the other steps we've done now. Actually, your last question on the test, the 1.4 test, or chapter 1 to 4, was finding Z-score. Like, we've been doing this for a while. So you know how to use that formula. Now it's just a matter of where do we need to look to find our answer. And that's the hardest part with this, is it's not procedural anymore. It's not, here's a formula, do this step, do this step, do this step, get the answer. It's, here's a problem, they're asking you something, okay, what procedure do I need to use to get that step? And it's not going to be the same for every single problem. All right? That's where the picture comes in. Once you can get the picture, then you can start to look at, okay, how do I find this piece over here? Well, I know I'm always going for the left, so I have to find this piece over here and subtract. It's like, or I need to find the piece in here, so I'm going to find this one, subtract them. Or I'm looking for this piece on the right side, on the left side, so I don't need to worry about that because that's what's going to give me. It's like, draw the picture though, and it really helps you figure that stuff out. Yeah.
It really helped just writing down.
What's up?
It just really helped writing it down to like just basic formula, like Z equals X minus mean
Over standard deviation.
Yeah,
Yep.
you were doing the thing where like the like Z equals X minus O or something like that.
No, it's mean. It's the symbols.
Yeah.
That's mean. That's standard deviation. It's just the symbols for it.
Yeah,
But yeah, writing it out in words, fine.
Yeah.
What's your question?
We're doing natural custom math at the end of class.
Okay.
That was on the practice test.
Gotcha.
It's like, we don't know what it is.
Gotcha.
How to do it.
All right. Try this one.
You can take it 99 times. And
Yes, I literally set the
You can take 599 minutes.
yes. I literally maxed out the numbers.
I took something, I've never been working on my.
Yes, next Thursday. And the review is on Tuesday. No.
Are you bringing candy?
I'm scary enough as it is as a math teacher.
Actually, not really.
Nicer math teacher.
I don't know. We'll see. I might bring something in. Probably won't be candy, but I'll probably bring something. I don't have kids to bring me home a stash, so I got to keep my candy myself. All right. Oh, let you finish. Keep working. Keep working.
I got my constant figured out.
So what would be the X value? Would we take the mean of 100 and 150?
You have two.
Okay.
I think that's.
Oh, okay.
This is like the very first problem we did. You have two of them. You got to subtract.
So instead of subtracting one by one, we subtract them by each other. Okay, keep it going. We'll do the same thing where it's like X minus. Okay. I'm getting it. Just
Oh,
I'm sorry.
So means 234. So I have a mean. I have a number here, and we'll do it here. So 100 and 150. I'm 34 divided by 94. Oh wait, hold on. Oh, I did it backwards. I'm so used to writing the bigger number first.
And for this, it's okay
Round. Yeah.
if I'm getting like 100 minus 234.
Yep.
That's negative.
Yeah, it's going to be negative.
Okay, cool.
All right. So you should have gotten both your z's should be negative. The mean, go ahead. I'm not going to find the answer yet. Keep working. So the mean is 0. I mean, sorry, the mean is 234. So both these numbers are less than the mean. So you should get negative z's. That's fine. Okay. You do not always have to get a positive. In this case, it actually is negative because it's on the left side of the mean. If you make them positive, you're going to get the wrong answer. Yeah.
So I would do 100 minus 234.
Yep. And then the 150 minus. Yep.
That- I think for me.
Yep.
Because you put 100 in here, I think that.
I did the same thing.
Oh, yeah.
No, yeah, I did the
Okay.
same thing.
Yeah. You don't need the 130 shoppers at all in this case. Yeah. Yes. Because you're not using this is talking about the amount of money they spent, which in this case is between 100 and 150. We're not talking about shoppers. The 132 is literally there just to confuse you.
Would you get the negative 0?
0.89.
Yeah, yeah. 'Cause
150 minus 234.
Got it. I just thought I was supposed to put the 4 in.
What?
Like I thought I was supposed to put like the 3 numbers together, so I thought I was supposed to.
No, your Z table is only up to 2 numbers. That's why I rounded to 2 places.
All right, cool.
So, all right. So now we're going to find those 2 Z's and subtract. And I haven't done it yet, so I physically have to look them up. Negative 143 is 0.07780. And 89 is 0.18673. So subtract 0.18673 minus 0.07780. So in here is 0.10893. As long as I looked at my numbers and I subtracted correctly, that should be the answer. Yes.
So once I get the 0.7780.
Yeah.
Minus it from the
0.18. Yeah.
and that's
And that's between them.
if I can just. That's what I need to do.
Yes.
They put something wrong with my calculation over here because I got -2.
No. You have to find the Z. You have to find the percents
Oh.
before you subtract.
Okay. Oh, okay. That explains it. Okay, cool.
What? 100 minus 234. Oh,
Wait, I got the same thing. Did you get 0.73? Yeah.
oh, you're right. I looked at 2, not 3. No. I counted over 3. Being stupid, I forgot the first one's 0. It was my fault. The process is the same. I'm not changing all my numbers. It changes that slightly, but I'm not changing my numbers. You're right. I was wrong. Good catch. All right. Let's look at this one. So the body temperature of adults are normally distributed with the mean of 98.6 and a standard deviation of 0.73. Okay. Everybody does not have a body temperature of 98.6. That's just the mean. And a standard deviation of 0.73. Okay. They want to know what temperature represents the 90th percentile. 90th percentile is 90% or 0.90. Okay, those are all the same things. So I'm looking at a bar that's somewhere over here. And this whole section in here is 0.999000. That's the information they gave me. And I want to know what X is. Okay? Yes, go ahead. Huh? No. I don't want the percent. I want to know the value.
Oh.
We're going backwards.
My bad.
So yes, this side 3.1 over here. So they want to know what the actual temperature is if they're if they're in the 90th percentile. Okay. So we need to work our way backwards. Okay. I've given you the percent on the left side, correct? So what can we use our chart to find now?
What, the decimal
The
value?
Z-score, right? So let's find my Z-score. That sounds right.
That's not right.
No, I said that sounds right.
You said that's not right.
Actually,
I think it's like 1
I would say 1.28 just because it's a little closer, but either one would be fine. I'm gonna put 1.28 though. Okay, so that's my Z. My formula was Z equals X minus the mean divided by the standard deviation, right? I know my Z, it's 1.28. I don't know my X. I know my mean is 98.6. And I know my standard deviation, 0.73. Now I have to do some algebra and solve for X. So, right. So I got to multiply by the 0.73. How to get rid of division. Hold on. So this is my formula, because I'll actually walk through the steps for this. So multiply by 0.73. So 0.9344 equals, now those cancel out, so x minus 98.6. So I got to get rid of that by multiplying both sides by the 0.73. Okay. Everybody good with that? And now I got to add the 98.6 to both sides. And I got 99.5 equals x. You're close. So for all those who work in healthcare, what's the temperature that the machine beeps you at if you think they think you have COVID?
All depends, but that.
That would be up there.
I think it was 100. I think yes. So if that's there, 10% of the people that walked in the door would have been beeped, and that's their normal temperature. Okay. So, although those frigging scanner things, like I got one that said I was at 93.2, and I'm like, I'm dead. They're like, go ahead. Like, all right. So, just like we were doing in the other ones, you can go both directions. That slide there.
Yes.
So x was 99.5. Okay, so we can go either direction for this and get the right answer or get a answer. It all goes back to drawing the picture and marking what they gave you, what they're looking for. Okay. All right. Let's see where I am. All right. Remember I told you a true curve? It's nothing to do with your grades. It has everything to do with the probability of people passing and failing based on the bell curve. Okay. So this teacher, and no, I would never curve this way because I actually don't think it's fair. Statistically believes that the final exam scores for a business class have a normal distribution of a mean of 82 and a standard deviation of 8. Find the score that separates the top 10% of the scores from the lowest 90% of the scores. Okay? Think about what we just did in the last question. It was the 90th percentile, right? That's all they're looking at for this. So what grade would represent the 90th percentile on this test? So do it and find out. Goes at 1.28, right? Yeah.
Once it's like 10% there. What do I search for? Because I got my 8.2.
You're doing the exact same thing we did here. This is 90%. You're looking for the z-score, which it's going to be the same z-score we had. And then you need to go backwards to find the x. So we're actually doing the exact same thing here. The only difference is the mean and the standard deviation is different. So what is, the z-score was 1.28, same as the one we just did. So you're going to multiply that by the standard deviation, which is 8, and then add 82. And what'd you get for the score? 92.82. Yeah, 92.24. So would a student who scored a 90 get an A? No, you'd have to get a 92 to get an A on the test. Okay? Only 92 and above would get an A on the test. You scored a 90 or a 91, you'd get a B. If you got an 82, what would you get? Because your mean average, if it's a bell curve, they set up the bell curve between 50 and 100. Your mean is 75. So if you were exactly at the mean, which is an 82, you would get a C. That's 75. So in this case, an 82 is the mean, so that would be the C range. So we're going to skip C. Knowing exactly what you know right now, what is the score for the lowest 10%? Do you have to find the z-score again? Why?
Because, well, I'm just thinking another way. You could just take what's left of the 92.4.
No. What do we know about a bell curve? It's symmetric, right? So if 1.28 gives you the 10% on the positive side, what would give you the 10% on the negative side? Negative 1.28. It's symmetric. So using the exact same thing, this time you can just use negative 1.28. So negative 1.28 times 8 plus the 82 gives you a 71.76. So if you got a 71 on this test, you'd fail.
You don't curve your
No.
test, do you?
The only time I'll curve, so when I do your tests, I find the average or the mean of the test. I want my mean to be between 75 and 80. If my mean is between 75 and 80, I determine that's a good test. If it's higher than 80, it was too easy of a test. If it was lower than 75, it was too hard of a test. If it's lower than 75, I typically do give a little points on there just to boost it up so the average is about 75. Because I feel like it was an unfair test for that. So, but I want my mean of the test to be between 75 and 80. And most of the time, I get there pretty good.
So the mean of the last test was,
I think it was 83, actually.
so would you say it's too hard or would you keep it?
No, that test was a little easy. For the general class. I think this test could be a little harder than the last test, just because of the way that the questions are. But it's the nature of the material more than me making it harder. So, all right. However, I've known professors that have scored that this is the way they score. But they scored everything this way, which means if their average on the test was a 45, you had people who got an A with a 60 on the test. Because it always holds true. No matter what the test they gave you was. It's not always on the good test, it's also on the bad tests. So if they gave a test that was really hard and everybody failed it, and they graded this way, the bell curve would still hold true. So if I said my mean, everything else stayed the same, and my mean was a 52 instead of an 82, you'd have gotten an A with a 62. And the only way you would have gotten an F is if you were below hold on a second, a 42. So anything between a 42 and up, you pass this test, even though everybody got around like the 52 was the mean. So that's also holds true if a teacher truly grades based on this. And I've known teachers do that. They're typically the very hard ones. So their grades are typically low to begin with. This helps average that out. Let's do this one. How many questions are on the practice test? I found 10 to be the sweet spot of about the decent number of questions, points per question, and amount of time you have to do it. I found 10 to be a good balance point. All right. Read this question for me.
Should we read it out loud?
No, just read it. Read it.
You're waiting.
No. I was giving you a chance to read. No, I would never make anybody read it out loud. All right. Is this continuous data? Or is this discrete data, this problem? Correct. Okay. This question's a true or false question, right? You either knew about the campaign or you didn't know about the campaign, right? Which is a binomial distribution, which we did in chapter 7. It's a discrete probability. So why the heck is I'm giving it to you now? If I wanted you to do this out the way you did the binomial distribution, I want to find out the probability of no more than 150 alumni knowing about it. We would have to do 0, 1, 2, 3, 4, all the way up to 150, right? Which would take you forever. However, binomial distributions have a tendency to act like a bell curve or a normal distribution, where they peak towards the mean and level off towards the ends. So we can treat this like a binomial or a bell curve and use all the stuff that we just found to find the answer to this problem, instead of going through and doing the binomial distribution or binomial probability 150 times, which would be a nightmare. So we need to do what we just did. We need 2 pieces of information, right? I need to know what 2 pieces of information, or what 3 pieces of information, actually, I should say, to do all the stuff that we just did. I need the mean, I need the standard deviation, and I need what? I need the X or the Z-score, right? I need one of the X or the probability, one of those 2 ways, right? So I need one of those 2 things. Okay. So I need mean, standard deviation, and in this case, it's the X. How do I find mean of a binomial distribution? Good practice for your test next week. That was one of the formulas you were given. So scroll back and look at chapter 7. Huh? Nope.
Oh,
Well, we only really have 3 numbers, right, in this whole problem. N times P. So that's N times P, which in this case, the number of people was 1,000, and my P is 20%. So my mean is 200. Okay? What's the formula for standard deviation? Standard deviation always has a square root in it. Yep, NP and then 1 minus P. So it's the square root of 1,000 times 0.2 times 0.8. Which that I can't do in my head. Wait, I think it's, that's better. So 12.65. And what's X? Okay. All right, so let's look at my bell curve. So we've got my mean is 200, my standard deviation was 12.65, and my X value that I'm looking for is somewhere over here, and it was 150. And I'm looking for less than that, right? It said no more than 150 if I remember. So I want this piece over here. So that's my z-score. What's my z-score? I'm almost done. I got one more thing to go. I know it's later than normal. You should have gotten negative 3.97. Why is it negative?
On the left side.
Right. Good. All right. And if we look at our wonderful little z-table chart, if I look for negative 3.97, I get 0.00004. Bless you. So what did I say? Remember way back when? What do we talk about after 3 standard deviations? It's a very small percentage. This is almost 4 standard deviations. So it's virtually impossible that only 150 people knew about this thing out of the thousands. I got one more slide to go. Almost done. I need to explain 8.4, which is literally going to take me 8.5, which is literally going to take me 2 minutes.
Wait, where did you get the z-score from?
Mean or X minus the mean divided by standard deviation.
Oh.
That's always how you find z-score. So that formula is always going to give you z. What's 150 minus 200? Divided by 12.65. Oh, you know what? I forgot the 5. It was 12.65. I forgot the 5. Yeah, that's fine. Sorry, I forgot I'm like, wait a second. Wait, I forgot that 5. Yeah. So it's 3.95 actually, not 97. Still virtually impossible. Actually, it's still the exact same number. So I'll change that, and the other number stays the same. All right. Okay. 8.5. There is a bunch of questions. They all ask you the exact same thing. They want to know if the data is normal or not, if you can use the normal curves. It's important to know, because if it's not normal, if it doesn't make a bell curve, none of the stuff that we did will work. Okay? Which one of these two histograms is normal data? Top or bottom?
Top.
Good, because it looks like a bell curve. So if they give you a histogram and it doesn't look like a bell curve, it's wrong. It's not normal data. If they give you a bunch of lines, it should make a linear line. Okay? It's got to make a line. So if you look at this data, does that point line make like that red line up on top? No, it kind of curves, right? Where this one kind of fits that line, right? This is normal data, not normal data. That make a line.
Yeah, no, I'm getting that, but I'm like.
You will never have to create this. The questions in 8.5 literally give you a graph and ask you which one's normal data. That's why I basically left it to the last line because that was all it asked. And there's only one question on the actual test on it, and it literally doesn't do anything. If you enter, which one's normal? Hi.
8.2 was really easy, like you said. I was
Yeah.
super surprised.
Yeah.
And I was like,
And 8.5 is really easy. 8.4, a little harder. 8.3, a little harder. But yeah, 8.2 is like nothing. And 8.5 is nothing.
If you want to drag it over your mark,
that's fine.
sure.
Yeah, no, that's fine. Thank
Oh.
you.
You're welcome.
Let me
Um,
know, like, text me
You're
if you're
more welcome to come whenever you want.
Probably the theater. She was
That's fine.
Early, so I called her to make sure she was safely at her, like, she was safe and not dead in the bathroom somewhere.
I might end up taking one class, but I have
Hey, that's
everything
your
in surgery
theater. Are you
next
talking about me?
Next week, yes.
Yes, and then I'll be out for weeks. I didn't know if you want me to do it on Tuesday or it doesn't matter.